you visualizing this? I'm trying to catch the early mistakes in advance. But make sense of it. What am I producing out of it? The gas is the only, this is the maximum that I could get out of my turbine. So even if you don't want to follow sign convention, you could just quantify, sorry, but right here. If you take this, this is your maximum work that you're going to produce out of that turbine. If I have that turbine not connected to anything, that's the maximum gas expansion that's going to happen through my turbine. I cannot, it's not physically possible. So right away, if I'm solving a problem and I use this form and I get a minus value and I have to add it, I'm busy calculating on my calculator or Excel sheet or MATLAB, and I realize that the work output that I get out of my turbine is more than my gas expansion. That's a red flag right away. Right? It tells me, no, that's something I'm doing is wrong. I'm getting work from somewhere. Somebody's giving me free work and I don't know where it's coming from. So make sense out of it. Question?
In the red writing there, should it be H4A minus H3? No, the line we were looking at on the bottom.
Yes, yes, you're absolutely correct. Why? Yeah, 4. Yeah, I don't know why I added 2. Why didn't anybody put it out? But essentially, I just flipped them. Sorry. So this is why nobody's asking questions? Yes, 4A because it's smaller, right, relative to 3, and therefore you're going to get a minus right here. That minus work plus the minus will give you a higher value, and by having that higher value, it doesn't make any sense because you know this is the maximum work you could ever get out of that turbine without even connected to anything. So when your work is higher, you're getting, as is mentioned, free work from somewhere. So that's not as a work that is actually going to the compressor. It's actually work that's applied into my system from somewhere. Questions?
Higher magnitude than standard. Basically, say that compressors and that turbine.
2 compressors.
Well, that's what you're saying. If you put H4A minus H3, because like you're putting more work in, right? Because your work out is.
Yeah, but if this ends up being negative, right? So what are you doing? You're adding those 2. But the system right here says that if I don't even have anything through expansion alone, so let's say I'm looking at the turbine alone, right? Not connected to anything. I have a high temperature gas going through the turbine and it expands. It's not physically possible to produce more than that. Think of you're running on the treadmill. I don't know how fast each person is, but mostly about a good 6 to 7 miles per hour at a reasonable pace. Well, somebody's quoting 30 miles per hour running wise on a treadmill. Does that make sense? No. And in reality, it's the friction that you might have tried to estimate that you added it incorrectly to your overall 6 or 7 miles per hour that you had. If you're trying to account for the overall energy balance, friction that's driven by your legs relative to the treadmill and so forth, and the friction that's driven by the treadmill, and then you're adding it more than it really is. So it has to be lower than the maximum value that you have. Does that make sense? Question?
So in terms of work out and work in, what is work net that we have from thermal transfer? Just work out in this case?
From your, no, I just decompose the work. But work net is, here is work out for the system.
Yes.
Yes, yes. All right, so let's try to complete the final equations here. So what do I have? So we're gonna cross this out, but we have it right here. So I end up with work out is equal to minus work CN plus m dot Cp T3 minus T4A. And from that, well, what do I don't know? Well, I computed work of the compressor. I know m dot, I know Cp. I know T3, so I know this, I know this, I know this, I know this. I don't know work out, and I don't know T4, so these are two unknowns, T4A, and I don't know work output yet. So, but I do know my efficiency of my turbine, and we already wrote it before. It's T3 minus T4A over T3 minus T4S, which actual versus isentropic makes sense because I can expand it to a full extent, but I can't because of my system efficiency. So this is one equation that we want to keep. This is the other equation that we want to keep. And from there, well, what do I know? I know T3. I know my efficiency of my turbine as my designer. Do I know for actual? No. Do I know for isentropic? Find it from where? All right, you guys are good. So T4S over T3 is equal to P4 over P3, and that's gamma minus 1 over gamma, which is your isentropic relations. From there, I could get my T4S substituted in there, and from there, I get my overall, my T4 actual, and I could get my overall efficiency for the system by saying, I already know my work output, or work net, work output of the cycle. Once I get my work output, I can get my efficiency. What is my overall efficiency? My thermal efficiency of my system? Very good. Now, if I want to expand it through the cooler, I can account for that, but right now I'm taking it as a propulsion system, so I only consider the compressor, the combustor, and turbine. And from there, that's my overall efficiency. And when you look at all these, what you get is 8 equations and 8 unknowns. And that's why you can't use the tables. There's so many variables to deal with. That's why we need the equations. And that's why you need MATLAB, or you need Excel, because you can vary these variables and get different answers, depending on the inputs you decide.